Hello, hello. This is the Maya Artifact episode number 4063. Today's date is May 2026. It's been almost like a night at 10:28 p.m. The problem of recording Artifact during the night, like specifically like today, is like really hot, like so much hot, like literally just like that, na. कि during the day it is hotter, yeah, it is kind of like a way much hotter than during the night. But the problem is that na कि during the night it's like it felt much more hotter than during the day. Why? Let me tell you one thing. Like basically there is a thing actually happened. It's a kind of like a thing that na कि the sunlight hit to the surface. Okay, now if the surface is soil, natural soil, then that natural soil is a kind of like a simply that key, it does not trap that much heat. Okay, probably like it trap heat, but like basically as compared to the asphalt and as compared to tarmac, it not really that much trap. But asphalt and tarmac and concrete are trap so much amount of heat inside of them. I don't know why, but it traps a lot. Okay, and when the sun cooled down, like when the sunset actually happened, then whatever during the day, whatever the kind of like a energy or heat trapped by the concrete, it just emit that heat. And the problem is that na he, like since we are living on the surface and since we are living at home and most of the homes are made of concrete and tarmac and asphalt and yeah, so that emit of heat kind of like a feel like so close together, like so close, like basically just like that. Now it's like I am kind of like at this wall and that wall is kind of like a somewhat something feel like warm. Okay, yeah, this is kind of like a things so much brutal. And during the night it just like I don't know why, but yeah, it's just like so much hot. By the way, is this thing that na ki it's not just a hot like a the where I live, like basically I'm living in Wardha, Maharashtra. Specifically, this is the Vidarbha region, is very much hot, like a Nagpur, Wardha, Akola, Chandrapur. These are kind of like one of the hottest city on the planet. Sorry, on the India. Also it compared to the planet. If I'm gonna say this thing, okay. Death Valley in US, they have a kind of like a very highest recorded temperature, like a 56 degrees Celsius. Well, like that is a kind of like assembly that is natural phenomena, by the way. But I'm talking about the kind of like assembly averagely where I live. Here is 40-45 degrees Celsius. It's just like so brutal, dude. So hot. Like I cannot able to be kind of like a tell you this is thing. This is like a really hot. And that's why I just cannot able to be recorded. Like what exactly happened now? Okay. So also is this thing. I did workout, and after I came from the workout, I showered, and after I showered, ate my kind of like a dinner, and after I dinner, I was kind of like a like basically is this thing after I ate my shower, after I kind of like did my shower, I just kind of like a sitting on the living room. We have only one cooler, and that cooler is on the living room, and we are actually sitting over there to kind of like a kind of like a feel little bit of cool. Okay, yeah, we have AC, by the way. We have AC, but still the AC is working. It's not really that AC is not working, but still the middle class mentality probably, yeah, like a basically a AC consume almost like a twice of the energy of cooler, so probably a cooler would be much more affordable, and which is true, by the way, because AC consumes so much amount of electricity and it does not kind of like give that much amount of output as compared to the cooler does. So yeah, we have only one cooler in the living room, and after I ate, after I kind of like simply just came from the workout, after I showered, I just wanted to sit in front of the cooler. Just, yeah, I just don't want to leave. Like, even if I don't want to kind of like go and kind of like do my work, no, I just, yeah, in my room doesn't really have any kind of like a cooler. I have just a table fan. Okay, yeah, and that table fan during the day, it's like yeah, so much warmer. And also is this thing, at my home there is a kind of like a construction actually happening. My father is actually building a kind of like a simply a room, and that's why it is a lot of construction actually happens, so a lot of debris and things and that, yeah. So this is also a reason to, but still one of the biggest reason to not to record artifact during the night is a hot, yeah, the summer. I'm eagerly waiting for the monsoon. I'm kind of like a thinking that ki when will monsoon came and when will I feel. And the problem is that na, when the monsoon will happen, okay, it kind of like feel even more warmer. Why? Because of that na ki humid, okay, humidity. The moisture it kind of like contained by the, like, basically is this thing. It does feel like, I don't know how do I supposed to explain this thing. Okay, yeah, like after the rain, and then there is a sunlight actually happen. That sunlight is kind of like a way much like a torturing. Probably, I'm not really sure the exact thing, but yeah. Oh boy. Also, let me kind of like tell you. Okay, have you ever understand the El Nino concept? Okay, so let me kind of like explain to you. I'm not kind of like a very proper and know the knowledge regarding about that, but still, okay, yeah, I'm trying to tell you, but do not believe on the information that I'm saying. Okay, all right. So there is a physics law. Is that ki when something get cool, get heavier, when something get hot, it's lighter. Okay, like if the water get hot, it is at the top. If the water get cooled, it's on the bottom. So basically is this thing that ki hotter thing, hot air, hot liquid, or whatever it is, it always stay on the top, and the cool cool thing like a cool water or cool air is always went into the bottom. This is the physics law, by the way. Okay, now what exactly happened that ki okay, so um let have you ever kind of like did something that ki warm up the water, like, have you ever done that? No, it's not really that much kind of like a things. Have you ever warm up the water in the gas? Okay, okay, if you are from the US and Europe, you might not have a gas. You might have a kind of like a simply conduction kitchen, probably like electric kitchen. Okay, like it worked the same, by the way. But have you ever boil up the water? Have you ever done that? It's not really kind of like a very like a very heavy science thing, so you probably done that thing. Okay, so when you boil up the water, how does kind of like a simply water get boiled? Have you ever kind of like a noticed something? How does kind of like a water get boiled? Are you actually thinking that ki, like, basically I turn on the gas, the because of the fire, the water get boiled? Yeah, but how? How does kind of like a simply when you apply the heat, how does kind of like a simply water get boiled? Have you ever know that? Um, okay, so let me tell you what exactly happened. So basically this thing, let's say you have a kind of like a kind of like a, you take a kind of like a simply a ganza. What is actually English meaning for ganza, I'm not really sure. Ganza means like that a pot, maybe it would be much more better. Okay, so a pot, a steel pot. Okay, steel pot. So you took a steel pot, you put the water. Now, whatever the water, tap water or whatever the water, so you put the water over there. Okay, at least maybe kind of like a, you feel that water at least like a 70% of the pot. Okay, now you put it on the gas and turn on the gas, turn on the flame. Okay, now what exactly happened that key like water is a like a normal temperature. Okay, like a, like every water layer is a normal temperature. but because of the bottom layer of water is so much easily contact with fire, like it's not really connected with the fire because of the there is a kind of like assembly, the pot is in between. Okay, yeah. And the pot is made out of steel, and steel is a good conductor of heat and electricity, not electricity but heat. Okay, yeah. So basically transfer the heat. So basically pot get warmer. So because of pot get warmer, the surface or the whatever the kind of like a surface which is actually connected to the water, which is kind of like a get hotter. Okay. So basically whatever the water is actually connected to the surface of pot is kind of like a getting hotter, and that hot water kind of like a became hot. Okay. That water became hot. The surface layer of the water. The surface layer which is actually connected to the pot. Now, because of the physics law is that whatever the things is actually hot, it become lighter. So that water which is actually connected to the surface of that pot, which is became hotter, and when it became hotter, it moved from position to like it's become lighter now. So when it became lighter, it goes upward. So when it goes upward, the little less like a little cool like a cool water replace the position. Okay, so this is a cycle actually happening inside that pot. Okay, so uh, cool water get down, hot water get up, and that cool water get kind of like heated by the surface, it kind of like a get hotter, it went up, then kind of like this is kind of like a cycle is actually happening. And because of this cycle actually happening, at some certain point, that entire water in that pot is became hotter. Okay, almost like a cross, almost like 100 degrees Celsius. And when it crossed 100 degrees Celsius, then it started boiling, because boiling start after the 100 degrees Celsius. Okay, yeah. Then kind of like a water converted into the evaporation actually happening. So this is kind of like a simply concept. Have you ever understand the concept? This is a very simple concept. Okay. Now let's talk about the El Nino. Like this similar concept is actually happening in the Pacific Ocean. Okay. So Pacific Ocean is a very big ocean. Okay. Very big part of the ocean. Sorry, it's a very like it's one of the biggest thing. Okay. Biggest thing means like that. Okay, if you not really understand the biggest thing means what. Okay, so when you open up the world map, you might not see the Pacific Ocean. Why? Because like basically when you kind of like imagine the map, you kind of like imagine a kind of like a simply 2D map. Okay, yeah. But map is not always been 2D. The planet is not 2D. The planet is sphere. Okay, and most of the kind of like assembly is covered by Pacific Ocean, which is actually connected by the American continent to Australia and Asian continent. Okay, so there is a kind of like a very so much amount of big space. Okay, and that is a water, that is Pacific Ocean, which is big. Okay, like I'm trying to explain how big it is, but you don't really understand the concept of the how big is that ocean. Okay, it's so big that probably is this thing now. If you kind of like assembly that key, if you cross the Pacific Ocean, then you might fit the Africa plus Europe plus almost like a if you like adjust little bit of Asia, then probably you could fit the Africa, Europe, Asia. Yeah, like literally you could fit the kind of like assembly is this thing, somewhat something like that. You could fit the almost like a 3 continent. Also there is some sort of space left, so you could attach the kind of like a Australia too. So probably that cross section of Pacific Ocean can fit Africa, Europe, Asia, as well as Australia. Almost like a 4 continent that you could fit on this size of the kind of like a Pacific Ocean. So it is that big. It's a very, very big ocean. I'm trying to explain how big is that ocean. Okay. Now you understand this concept. Okay. The first concept that you understand is that water is a kind of like somebody goes hotter, it get lighter because of you understand the revolution. Now you understand the Pacific Ocean, how big is that. All right, now let's try to understand, like basically in the end it all makes sense. I'm gonna tell you another concept. Okay. Now our planet is not rotating in its axis. What the fuck that you are saying? Okay, like, that is a completely shit. Like, the planet is rotating, like that's why we have kind of like a day and night. Yeah, that is true, but it's not the rotating the way that you kind of like simply imagine. Like, if you are thinking that na ki your planet is kind of like a rotating, like basically just straight, but it's not straight. Your planet is kind of like a tilted. Okay, let me tell you. Have you ever seen a globe? A like globe, kind of like a globe toy you've probably seen. Like, you probably seen it. It's not like that you only seen it, right? Right. Imagine that globe. All right. So that globe is always tilted. Why if you made a globe, you have to make a globe as a straight. Now why are you kind of like a tilted? Have you ever imagined why does kind of like they make a globe a tilted? Like, if you kind of like a rotated, it's a tilted. Why it's tilted? Because it is actually, our planet is tilted. It's not rotate on the like a perpendicular axis. No, it's a kind of like a rotated, little bit of slightly tilted. That angle is a 23.5 degrees Celsius. Okay, so this is kind of like a rotation actually happening. So what exactly it means? Okay, yeah, what exactly that means? Okay, so because the way that we actually experience the heat, the winter, the rain, these are the season, are actually came, or also the atmosphere, it also came because of this kind of like assembly axis, like because of this kind of like a tiltation. If our planet, our earth planet, is rotating on perpendicular axis, then we might not have a atmosphere, we might not have a season, we don't even exist, by the way. Yeah, that is a kind of like a really essential, like because of earth is actually kind of like assembly just rotate on 23.4 degrees Celsius. That's why we have kind of like a season, that's why we have atmosphere, that's why we are kind of like a simply living breathing animal. Okay, the life is kind of like exists is because of that key. Our planet is kind of like a little bit tilted. Okay, and mostly it kind of like a create a season. Okay, so okay, so but how is that actually happening? It's a very cool concept. Okay, so let's take a kind of like a very simple example. Okay, so when you run, okay, when you run, you feel wind, you feel wind, right? Like, have you ever kind of like a drive a cycle or bicycle or motor drive, you feel that wind, right? Like, how you kind of like a feel that wind? Because you're going forward now, you are going forward, and that's why you are kind of like assembly feeling that much wind. But if you are walking, you are might not feel that much wind, that much kind of like a resistance of wind and things and that. Okay, so same thing actually happen on the planet too. So our planet is kind of like a rotating. Okay, but our atmosphere is not connected with our kind of like a planet. Okay, let me kind of like something tell you. Okay, it's a kind of like a very weird. Okay, so our atmosphere is a gases. It's not kind of like a solid thing that atmosphere and are connected. No, it's a gravity is a connection, but gravity is a kind of like a force. All right, our surface and our planet and oceans are actually connected by the kind of like a surface and things and that. So when the planet rotate, the continent rotate, the ocean rotate, things and that. But atmosphere, it does not. It does rotate, but it takes time. It takes time. Okay, if you not really understand the concept, I'm gonna kind of like give you another example. Okay, it's a very simple thing. Okay, have you ever kind of like somebody do a laundry? Okay, by the way, if you are kind of like doing a laundry in washing machine, by the way, today's washing machine are kind of like a very advanced. Okay, yeah, like a, they have a kind of like a simply a bucket of like a horizontal bucket. Okay, so you could put the things, and like a horizontal means like that key, like 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 a horizontal, like RV. Okay, horizontal bucket, you put the kind of like a things, and that horizontal bucket kind of like a rotate, and the clothes are kind of like a things. But this is the new advanced machine. Previously previously, almost like right now I have a kind of like assembly washing machine, and that washing machine is a vertical bucket machine. Now what exactly vertical bucket means? Like the bucket is like basically what is actually the mechanism of the washing machine is that a washing machine bucket is kind of like a rotate. Okay, so what you have to do is that you put the water, you put the clothes. Okay, so basically what exactly happened that key the vertical bucket. Okay, so when you have vertical bucket, you fill up the water. Okay, and you fill up the water and you put the kind of like a clothes. Okay, if you put too much amount of clothes, then what will happen that it clog. Okay, yeah, basically it does not kind of like a wash that much properly. Okay, yeah, so you make sure kind of like a water is too much, and so that kind of like assembly that kind of like assembly clothes are kind of like wash them properly. Okay, so when that bucket rotate, okay, yeah, okay, have you ever seen that how does bucket rotate? Okay, okay, if you not really understand, okay, let me kind of like tell you. The bucket rotate for clockwise, then anti-clockwise, clockwise for kind of like a 2-3 second, then anti-clockwise. Okay, this is kind of like a thing actually happening. So when the kind of like assembly bucket rotate clockwise and anti-clockwise, so because of the water flows clockwise. Okay, because of the bucket flowing clockwise, then suddenly bucket rotating anti-clockwise. So when the bucket rotated anti-clockwise, but the water is kind of like a flowing to the clockwise, so it kind of like a create the resistance. And when it creates the resistance, it kind of like assembly is this thing that key the water it just kind of like assembly just create the resistance. It takes time to adopt the rotation. It takes time to adopt the rotation. Okay, like it's kind of like, have you ever seen that thing? It's a very simple thing. Okay, yeah, okay, if you have a kind of like a somebody like a horizontal bucket, then you might not seen that thing, because like this might like it does not work in the horizontal bucket, because in the horizontal bucket are kind of like a really good to washing the clothes. But if you wanted to understand this concept, then a vertical bucket washing machine would be kind of like a much more better. I have this kind of like a machine which is kind of like a somebody almost like a kind of like a little less upgraded version. The horizontal bucket is kind of like a very upgraded version of washing machine. But yeah, you get my point. What I'm trying to tell you is this thing that key the water kind of like a getting the resistance when the rotation of the bucket actually happening. So same thing actually happened with our planet too. So when the planet is actually rotate, okay, yeah, now planet does not clockwise or anti-clockwise. It does not kind of like do this thing. Planet always rotating clockwise direction. Now because of planet is actually rotating on clockwise direction, the atmosphere act like a basically in the bucket, the water is also act like an atmosphere. Like a basically atmosphere is actually connected with our gravity, but it takes time to kind of like a simply it takes time to kind of like a simply rotate along with the surface. Okay, yeah. So because of this thing, it creates a kind of like a simply the wind pattern. It creates the wind pattern because when the entire planet is kind of like a rotate around its own axis, and the atmosphere is a kind of like a stay little bit stable, and then after that it kind of like a rotate along with this thing, it create the wind pattern. Now another thing is that now our planet is kind of like a way much bigger, and there are so many kind of like elements on our planet, like mountains, trees, and things, and that and that and that and that. So because of this thing now our kind of like a wind pattern get disturbed by mountains, by things, and that and that and that. So it create that wind pattern. And because of that wind pattern, what is actually happened, let me tell you one thing. The earth equator atmosphere is rotating much more faster. But if you went to the kind of like a little bit kind of like a somebody little bit closer to the equator and like a pole, if you went to the pole, then kind of like a atmosphere is not rotating that much fastly. In South America, sorry, in South Pole, things are very different. We are not going to talk about that, but I'm not talking about the pole. I'm talking about kind of like somebody is this thing that the the equator atmosphere is kind of like a rotate much more faster than other layer of atmosphere, like a, basically just a upper layer of equator, like a, basically just like we have, like I'm not really, like I don't really have any kind of like a words. There is a kind of like a words for name is a equator, I don't know. I'm not really sure about the kind of like a things, but this is what it is. Like basically the layer of atmosphere is a kind of like a difference actually happened because of that key. The central layer of atmosphere is kind of like a rotate much more faster, so it creates faster rotation, and because of it create faster rotation, it not only create the resistance from the surface, it also create the resistance to the other atmosphere layer too. Okay, yeah, like okay, if you're not really understanding the things concept, okay, it's a like a, right, if this video artifact episode now, I'm gonna kind of like tell you very much properly regarding about the hand gesture and things and that, but because it's the audio artifact, okay, yeah, let me kind of like explain to you. Okay, so basically what exactly happened, let's kind of like simply imagine kind of like simply like a like a basically take a hand. Oh yeah, take a hand. Okay, your palm of your hand. Okay, so your make sure your palm of hand kind of like a, okay, it's a very hard to explain this thing. Okay, uh wait. Okay, so basically is this thing that key, um it really required a kind of like a visual representation. You might not understand what is actually concept of this thing. Okay, because of the limitation of the things that I'm trying to tell you. Okay, so try to understand the concept. Okay, yeah, it's really required a kind of like a visual representation, but still. Okay, so every layer of atmosphere acted very differently according to the kind of like a something, because of our planet is much more bigger. Okay, yeah, and because of our planet is actually much more bigger, the equator atmosphere much more kind of like a flowing faster than rest of the kind of like atmosphere layer. Okay, yeah, so when the rest of the atmosphere layer is kind of like a flowing that much less faster, okay, yeah, like it kind of like a flowing but little bit less faster, so it create the two atmosphere layer are kind of like a creating a disturbance, and that disturbance create a cyclone. Okay, cyclone, it's not lit too much. Okay, yeah, but if it too much then it creates a cyclone. Okay, the cyclone is on the ocean, it called cyclone. That cyclone is on the surface, that called hurricane. Okay, there's a two different kind of like definition for that. If that cyclone is on the ocean, it's called cyclone, like the like we call it bhavandar probably. Okay, yeah. And that bhavandar on the surface we call that hurricane. Bhavandar is a kind of like a Hindi word for that. All right, so basically is this thing that creates that kind of like assembly that key, kind of like assembly wind kind of like a things. Okay, yeah, because of the kind of like assembly atmosphere layer kind of like a differences and things and that. Specifically in US, things actually happen more. Why? Because of that, he the this El Nino, this kind of like a things actually happen. This kind of like a thing actually happen in Pacific area more. Okay, why does only happening in Pacific area? Like basically, what is that happening in the rest of the planet? Okay, yeah. So basically, is this thing in the rest of the planet, like our planet is actually kind of like a something almost like a like basically almost like a 60% actually covered by land, not 60%. Okay, yeah, like okay, basically 60% of the kind of like a 60-70% of the kind of like assembly planet is actually covered by the water. Okay, and most of the chunk are actually in the Pacific Ocean. Now Pacific Ocean on the back is a complete clean slate. Okay, there is no disturbance at all, there is no in between kind of like a kind of like a some any kind of like assembly the continent over there, nothing really at all. It's just kind of like a American continent, and then there's a Asian continent, and then there is a like a Japan and kind of like Australia and things and that. So this is the entire Pacific plate is a completely empty. There is nothing really at all. Okay, yeah. So because of there is no nothing really at any kind of like a continent in between. So because of this thing, there have higher chances to have a kind of like a much more cyclone it creates. Okay, yeah. And because of it create much more cyclone, it's kind of like a easier to kind of like a travel somewhere. And because of earth is kind of like a rotate east to west, so basically that hurricane kind of like a went east to west. So basically the like it's a kind of like a thing that the hurricane actually kind of like a created in kind of like a mid Pacific and things and that it flows and then kind of like it hit to the American plate. Okay, yeah. North America plate specifically. Okay, yeah, because South America is a kind of like a little bit less away, like a little bit of kind of like away than that. But kind of like a North America is kind of like a hit by cyclone very quickly, and that's why the North America they kind of like a getting lot of kind of like a simply the cyclone and hurricane. Like over there, hurricane and kind of like a simply happen much more than rest of the country, rest of the planet. Okay, now okay, so this kind of like a difference layer, okay, difference kind of like a things. Okay, but this concept is kind of like a way more crazy. Okay, yeah. So El Nino kind of like a creates a hurricane in the North American plate. Okay, mostly. Okay, and it with the higher kind of like, so that's why kind of like in the Hollywood movies they kind of like have kind of like some hurricane movies and kind of like a things and that. But in the rest of the planet we don't really experience that much kind of like a thing. Okay, in Japan or maybe Australia, but not that much, because it's a kind of like a things that ki Australia is kind of like a bit became little bit bottom, so it's not really that much affecting that much. North America is actually affected by the kind of like a hurricane, mostly because of that it's a kind of like entry gate. Okay, entry gate. Okay, do you understand this concept? Now let me, there are so many kind of like things are associated with this. Okay, so what exactly happened? Okay, so our earth has a kind of like a two hemisphere, northern hemisphere, southern hemisphere. Okay, like if you have a kind of like a cut down in half, so basically northern hemisphere means like that ki Europe. Okay, entire Europe, North America, Greenland, Sweden, everything, Russia is on the north hemisphere. South hemisphere is a kind of like a simply half of the India, Australia, New Zealand, Antarctica, then South America, then half of the Africa. These are also in kind of like simply southern hemisphere. All right, yeah. So basically, what exactly happened that because of Earth is kind of like a tilted 23.5 degrees Celsius, 23.4 degrees Celsius, it's kind of like a tilted. So because of it tilted, what exactly happened that a kind of like a somely southern part of kind of like a something southern part of hemisphere is kind of like a getting much more hotter. Okay, yeah, as compared to northern hemisphere. Okay, how that actually happening? Okay, same kind of like a thing. Okay, take a ball. Okay, like not take a ball. Okay, the globe. You imagine a globe. Okay, the toy globe that kind of like you could see. You imagine a globe. That globe is already kind of like a